Sometimes in organic chemistry, we need to know where on the periodic table an element shows up. And the periodic table at the beginning in chemistry can seem a little intimidating. Columns and rows and where are the elements. And you maybe don't want to spend a lot of time memorizing all of the periodic table. But it is valuable to be able to quickly know where some important elements are on the periodic table. So today, I want to teach you just the most important elements for organic chemistry, where they show up on the periodic table, and some easy ways to kind of remember where those elements are and to see how it might be a little bit useful. So let's jump right in. So here's our periodic table, tons of elements, and we want to figure out just the most important ones for organic chemistry. The good news is there aren't very many that we have to worry about. It's just these top elements. So here's how I remember those most important elements, where they show up on the periodic table. The first thing is you might just think, this is ridiculous. How can we learn the elements of the periodic table? So you just start to chuckle to yourself. I can't believe I'm supposed to memorize this. So that's where the first elements are. Hydrogen and helium. These top two elements are the first ones on the periodic table. Hydrogen we'll see all the time in organic chemistry. We won't see helium, but is where the first ones are. Now the second row of the periodic table, we'll use these over here in the periodic table, but I like to learn this entire row. And the way I remember this row is, I think back to that movie, The Lion King, and there's that scene where Timon and Pumbaa, is that their names? The warthog and meerkat, I think is the other one. And they sing a song in Swahili. They sing Hakuna Matata. And that's Swahili for no worries or no problems. Hakuna Matata. But we're not going to speak Swahili right now. We're going to speak chemistry. So in chemistry, no problem is Liba Biknafna. I'm just making this up. But Liba Biknafna means no worries for the rest of our days. So Liba Biknafna. Liba Biknafna, what a wonderful phrase. Liba, lithium and beryllium. Biknafna, boron, carbon, nitrogen, oxygen, fluorine, and neon. Liba Biknafna, what a wonderful phrase. So if you can remember, and Liba Biknafna, that gets you the first two rows of the periodic table. Now, there's just a few more elements we need to know for doing almost all of organic chemistry. Now, the next two we're going to get right below nitrogen and oxygen. And when I was a kid, my parents would feed me peas, green peas, and I hated peas, so I did not want to eat them. So for me, whenever I think of peas, I'm like, no thanks. So for me, no peas. Nitrogen, oxygen, no. Phosphorus and sulfur, peas. No peas. So nitrogen and phosphorus have similar chemical properties, and oxygen and sulfur have similar chemical properties because they're in the same columns. Now the last few we're going to learn are the halogens, and the ones that are below fluorine. And the way I remember those, so I have Liba Biknafna, no peas, and the halogens, I think of a parade in somebody's hometown, and they're going to have the parade, and they want to bring everybody out to the parade to see the exciting things that are happening. So the first thing you want to put in the front of the parade are clowns. And I like to picture in my head clowns riding little tricycles, just riding in random disarray and all over the place just to try to draw in attention. And in fact, the best clowns on little tricycles, to really make it funny, are big fat clowns. So we realize that fat clowns bring in attention. And that's the mnemonic I use to remember the halogens. Fat clowns bring in attention. So fluorine, chlorine, bromine, iodine, and astatine. Now these are the most important ones for the periodic table. Hydrogen, carbon, well, we might use boron a little bit, phosphorus, and then these halogens right here. So that one and these are probably the most important ones for us to know for organic chemistry. Let me just give you a brief glimpse into why we might care. So if I number these columns 1 through 7, and we'll go ahead and go over to 8 for the noble gases, all of these want to be like the noble gases over here. So if I'm thinking about these and I'm like, all right, fluorine, what kinds of chemistry does fluorine do? Well, fluorine starts out with 7, it's in the 7th column here, 7 valence or outside electrons. So it wants one more electron to get to 8 to be like this stable neon. So what happens to fluorine, it starts off with 7 and it likes to make one bond. So now it has 2, 4, 6, 8 available to it. It likes to make one bond normally. So fluorine and chlorine, normal bonding for chlorine would be one bond and 3 lone pairs of electrons. Normal bromine would be the same. All of these want just one more bond to be happy. Now how about oxygen and sulfur? Well, oxygen and sulfur, oxygen wants 2 more electrons to be like neon. So it starts off, since it's number 6, with 6 electrons around the outside. So maybe 2 single bonds and 2 lone pairs is normal oxygen. So normal oxygen might look something like this, or normal sulfur would be something like that. Nitrogen and phosphorus, they want 3 bonds to be up to 8. So normal nitrogen is 3 bonds and a lone pair. So nitrogen starts off with its 5 valence electrons and makes 3 bonds. So nitrogen might be a double and a single would be 3, or a triple bond would be 3. Those are different ways to have nitrogen or phosphorus. Normal nitrogen or phosphorus. And of course, carbon wants 1, 2, 3, 4 bonds to be like neon. So carbon starts off with 4 valence electrons. It's in column 4. And it likes to make maybe 4 bonds as 4 single bonds, or a triple and a single, or a couple of double bonds, or maybe a double and 2 singles. That would be normal bonding for carbon. So you can see, knowing those few elements where they are on a periodic table helps me know something about how they react. So I hope that helps. How to memorize where the first few elements that we'll use a lot in organic chemistry, where they are on the periodic table. Liebignaffna, what a wonderful phrase. No peas for me. And remember, fat clowns bring in attention. Hey, hit that like and subscribe buttons so more people can find out about this channel and I can help more people learn organic chemistry.